Right, so well, welcome to this session entitled Dynamic Search Conditions. Let's see, I'm always going to start. I always end up clicking, having the focus on when I start with the title slide. Anyway, let's move on. First, just a quick about me. So my name is Erland Sommarskog. I live in Stockholm, where I work as an independent consultant, and I have been an MVP for SQL Server for many years. And I have a website, sommarskog.se, which you can say is a small collection of large articles that goes in depth in a couple of topics. And one of these articles is actually called Dynamic Search Conditions. And this presentation is, well, not the full article, but well, the article in a slightly different form. But if you read the article, there will be a few more tidbits. Anyway, there's also my email address, sql@sommarskog.se. So if there's any question that you're more than welcome to just interrupt and ask questions either in the chat and I hope that Damir will monitor that and ask and interrupt me if there are any questions. But if there is anything that comes to you after this session and you think about, well, please feel free to drop me a line. I'd like to point out that you'll find slides and scripts for my presentation at sommarskog.se/present. It's already there. I'm including the database. You will see this at the last slide as well. So what I'm going to talk about, well, in many applications, well, users want to be able to search the data on various conditions. So let's say we have an order database. They want to find orders based on, well, of course, the order ID, some date interval, the customer's name, the customer ID, the customer's city, the customer's shoe size, you name it, or the product or whatever, all sorts of properties. And of course, they want correct results for the searches. But not only that, these pesky users also insist of getting good performance no matter what they search for. They don't like sitting waiting for hours to get results of a search. And this is the task we were going to look at today. Now, we're going to work on a database called Northgale. And this one has it's an inflated version of a database, an old demo database from Microsoft called Northwind. And this Northgale has 1 million orders, which is big enough to show that some solutions doesn't work. But you can imagine that the real order database might have 100 million orders or even more. Now, there's two ways to do these searches, two ways to go. You can use static SQL and you can use dynamic SQL. Now, it's not the case that one of them is better than the other. No. They supplement each other very well. So where one is strong, the other is poor, and vice versa. And what is related to is the complexity of the problem. As long as the problem is quite simple, it's just a bunch of conditions, all in the same pattern, static SQL is a lot easier to work with. But if complication appears of various sorts, that could, for example, be, well, you want dynamic sorting or call frequency could be a problem. We've got to look at these. Now, dynamic SQL will be a better choice. Because with simple SQL, when you start to add things in complexity, well, the curve goes like this, very steeply. Whereas dynamic SQL starts on a higher level, but then grows linearly with a fairly small slope, again in the complexity. So that's why we need to look at both. And I will start with static SQL, and then on the second half, I will go dynamic. This is the search task we're going to work with today. So first, well, now here's a bunch of columns we're going to select from these tables. Slightly more of interest is the join conditions. So I have an orders table that I join to an order details table and to a customers table and a products table. Now this join spans a number of order lines, and we're going to search for order lines. Maybe in the real system, if someone gives a product name, we might want to show the full order with that product on, but we're not going to do that. That will be too complicated for the task today. So these are the search parameters we're going to expose to the, well, not the user, but to the application. So you can search for a specific order, and obviously that's the primary key in the orders table. We can search for a status. And it's 4 possible different status for an order in this database. It can be new, it can be in processing, it can be E for error, or C for completed. Now, most orders in this database have status C, more than 99%. So there is an index on the status column. But given the fact that the C value is completely uninteresting to index, it's a filtered index, so which excludes the C values. And that's going to present some challenges that we're going to look at. Then we can select on the order date. And we can be of intervals, so we can say from date to date, and well, we can just only say one date if we want to. And of course, there is an index on the order date. We can search on a customer ID, and well, yes, it's an NCAR5. That's because, well, the Northwind database, for some reason, they have an NCAR5. well, it's just the way it is, and I just haven't changed that. And then you can also search for a name of a customer, and that's the way it works. If you enter, it's a starts with. So if you enter BLA, you will get a hit both on Black and Blake, for example. And then there's its index on the customer name, and you can also search on the city or the region for the customer, and you can search for specific product either by ID or by name. And again, that's the starts with. Now, so here, let's look at the general search pattern for static SQL. So this is the basic pattern we're going to work with, although we will need to make some small tweaks before we get to the final solution. But you say order ID equals at order ID or at order ID is null, O status equal at status or at status is null, or order date greater than from date or at from date is null, or customer name like customer name plus % or custom is null, and so on. So if now take as an example, we're going to search for orders from, well, customers in split and that were placed today or yesterday or in the future. We're just going to say from date. So anyway, if we look at this, so we don't have an order ID. So this means that, well, this condition is true, so we can just ignore it. We don't have a status, so this condition is true and we can ignore it. And it goes on like this. And, well, from date, we do have a value, so we can ignore this part. And the same thing for city. So logically, this is what we have left. Give me orders where the orders equal greater than equal from date and city equals at city. Now, that's the logical part. What about the performance? Well, let's give this a test. So here I got a procedure called static search 1. That will be, yes, there will be more than one of these today. And anyway, here are the parameter list, the one we saw before on the slide. Now data types. Here we have the select columns. Here's the join again, and here are the conditions that I showed you. And gonna go and create this guy. And I'm going to start with making us one single search on the order ID to get something into the cache. And we can see this one seems to be fairly quick. Now I'm going to make 3 different searches, one on order ID, one on the new orders, and one on orders with a specific product. And I'm also going to capture the time. So I'm going to first start getting sysdate time, and then I'm going to compute how many milliseconds it took using the dative function and print that out. So let's run these, and well, that search and order ID took 437 milliseconds. That's perfectly okay for users because they're going to accept anything which is below 1 second. But the search for new orders, that was more than 7.5 seconds. Maybe not really the final solution because that's a tad slow for them. And the search for product, it's still going on, and it still is going on, and it will go on, I believe, for quite a few more seconds. So this is the part of the presentation where I just talk without saying anything at all because I'm waiting for the results. Yeah, all we can say though, this is just too slow. So we need to improve this. But why it's slow, we're gonna get some understanding about that. Once this has completed, and it takes, oh yeah, almost 40 seconds. So it's way too slow. Now, actually we're gonna run this again, but first I'm gonna run this again. But why? Well, because I'm going to do recompile of this procedure. So I'm going to recompile it, and then I'm going to run it for the product ID. And all of a sudden, that's not taking 40 seconds anymore. It's taking, well, it was, well, less than 2 seconds. So anyway, including the compilation. So I'm going to run these 3 searches again. And now, well, the search from order ID, I mean, that's the search. We're going to search on the primary key. So we wanted to go right down to the primary key, right down in the index, get the row, but it doesn't seem to do that. No, it's taking a very long time. So why is this? Well, we have one stored procedure. And as you may know, SQL Server caches execution plans for stored procedures. And that's one single plan. Now, first time when we sent in an order ID, SQL Server, because always when you create a stored procedure and run it the first time, SQL Server sniffs the input parameters and uses those values of the input parameters as guidance. Say, okay, I got an order ID. I'm going to optimize this plan so it's fast for an order ID. This time it's optimized for a product ID, and it's not so fast for an order ID. And it still hasn't completed, and it's just taking way too slow. So, but what is the lesson here? Well, of course, we got one single plan. But obviously, if we're searching for order ID, well, then we wanted to use the index and order ID. If we're searching for a product, well, then we wanted to use an index for the product ID in the order details table. So that's the key. We want different plans for different search conditions. Oh, that's unusually slow. Over 1 more minute. It usually takes like 30 seconds. Oh, well. So Oh, let's see here. We don't gonna wait for the rest. That's because that takes us too much time. So anyway, the plan is optimized for the first search, as you call parameter sniffing. And what we do need different plans for different search conditions. Now, but before we get there, though, I like to call out for this little trap. Sometimes when these questions comes up in forum, some people say, use this instead, this is faster. So they say, do this instead, already equal is null at already, comma already. So if already is null, well, then we have a truism, already equals already. Well, could this be faster? Think about this for yourself for a second before I will open this. And so I got now static search 2, and I've changed all these conditions to use is null instead. So let's create this guy and run this for the search in order ID, see what we think about this. And we think it's bad because the result is wrong. We don't get back end results at all, although here we did get results for order 11,000. And why is this? Well, the answer is here, the region column. Notice here, it's null for this customer. There is no, there's no region registered for this customer. And so what does this mean here? Well, so this one is null. Okay, then we have null equals null. Now, in SQL, null stands for an unknown value. This means that if we compare, well, let's say 5 to null, we don't know whether they're equal or not, because that null could by chance be 5. It's unknown. And so, even if you're comparing two non-null values, well, they could be different values or they could be the same. Well, in this case, it must be the same value because it's the same column, but there's no special rule for this. So, because the outcome is unknown and not true, this row is filtered out. So this was a bad idea. So this is a trap. Don't use this because you get the wrong results. And no, it does not run faster because it has exactly the same problem as the other one. It's one single static plan. That's bad. Now, let's do this. Try this instead. We've got different plans for different search conditions. We don't need to do this. And so one thing we could do is use this with recompile, create procedure with recompile. So we tell SQL Server now, recompile this procedure every time. Could that be something? Well, let's try this. So static search 3, and it says now with recompile, I've gone back to the condition with or. Yes, this is slightly longer than the one with this null, but it's a lot better because it only gives you always give you the correct results. So I'm going to try this, going to create this guy. And then I'm going to run these searches, and let's hope they run faster now, or else this presentation will take a very long time. No, but they will run faster. I know that because I've tested. Yes, well, 534, 813, and 1291. This one is a tad slow, but yeah, it's decently okay. The users might be able to accept this. But keep in mind, we only have 1 million orders in this database. What about production, where we have 100 million orders? Is there any way we could have, from this database, get an idea whether it should work in production or not? Well, we can look at the query plans. Let's do that. So let's see here, and we expect it now to use the primary key index for the orders ID when searching for an order. And let's see now. And now it says index scan ship IDX. So it's making a scan. Now, it took over 500 milliseconds for 1 million orders. Imagine now if you have 100 million orders, it's going to take more than 50 seconds. No. Users are just going to throw rotten tomatoes at us if we present them this solution. So we need to work harder. But just in desperation, we can just try also the searching for new orders. This one should use the filtered index. Does it? Let's see here now. That's a clustered index. Clustered index. Clustered index scan. So again, it's going to take 100 times longer with the full database. So why is this? Well, so although SQL Server now recompiles the procedure every time, so if you send in an order ID, it's going to optimize the plan for an order ID. It still can't seek the index because there's one piece in the puzzle that SQL Server doesn't know, but it knows that it doesn't know because maybe there are some statements between the start of the procedure and this select. For example, it could be like, well, a from date is null. We're going to set from date to some hard-coded date, like the start of the year or whatever. Or if the city is not given, it's always going to default to London or whatever. Or that could be all sorts of funny things. So SQL Server must take into account that the variables might have changed, or the parameter have changed values until we reach the select statement. So it must make a plan that is always correct, always give the correct result, no matter the value. Because although we like performance a lot, correctness always trumps performance. No surprise. So this was better, but it was not good enough. And well, because the optimizer must consider that the parameter could change before the query runs, and therefore we have scans. So we need to try something else. Then we have this query and option recompile that we can put at the end of the statement to tell SQL Server every time you run this statement, recompile it. So let's try that. Static search for. So there's no with recompile here anymore, but now it says option recompile down here. And let's run this. And again, I'm going to run my searches, see what I get. And are they all 30, 296, and 499? Yes, absolutely faster. But again, we want to get some ideas by looking at the query plan. So let's try this. Let's see here. Clustered index. We can claim success. Clustered index seek. That is exactly what we wanted, a search on the primary key. So now we can assume that, well, if we've got 100 million orders, well, that will be a few more reads because the index trees is deeper, but it's nothing. It's going to work. That's all right. We can also verify this for the search on new orders, see what this one works out. It's index seek on the status index. So yes, we got the index that we wanted to use. So why does this work so much better? Well, now, because this time we're only recompiling this statement. SQL Server does not have to consider that the variables could change values, but it can be a lot more aggressive. So let's say we're making a search for new orders. Well, order ID is null. So okay, SQL Server says, I can just throw this condition away. And same goes for all these other conditions. I can throw them away. And status is, well, I know there is a value. There is at n. Oops. N. So it's actually the same thing as we have submitted this actual query, because now the SQL Server can handle them as constants. So this is the key to success for these searches. We need to use optional recompile, compilation every time, and then we can use exactly the index. But wait, there is more. There is more to it. So down here, I got, well, this is the same search profile. I'm giving a custom ID and a date interval. So it's the same search parameters. But they're still quite different because this guy, ERN2C, this is the customer with 10% of the orders in Northgate, by far the biggest customer. And the date interval is just a single day. Bonusar, on the other hand, there's just one single order, but the date interval is a full year. So let's have a look at these query plans. And see this one here, you can see it's index seek and index seek. It uses both the index and order ID and custom ID. There is no combined indexes that have both order ID and custom ID. That would be a great thing to have for this query, but there isn't. And then it actually makes a hash match of these two. This is not a pattern. It's called index intersection, I think. You don't see this very often, but sometimes SQL Server can do this, seek two different indexes. Now let's look at the other search. And at first glance, it looks different. It seems different, but if you look, it seems to be the same. But here it's index seek and here it's key lookup. So now it only uses the index on custom ID because the date interval is so long, it's a full year. And in total, I think there's only data for 6 years in Northgate. So this means that that's one sixth of the database. That's just too much for an index seek. So it's only using the index on custom ID. So this means that not only do we get different plans depending on the parameter profile, but also depending on the values. That's really, really great. So back to the slides to summarize. So because the SQL statement, only the SQL statement is recompile, all the variables can be handled as constants. And here they were all parameters, but they could also be local variables, and they will always be handled as constants. And when you make these kind of searches with static SQL, you always need this hint. Or, well, there's almost in parentheses, because there are a few exceptions. I will touch one very briefly, and with those one special case, I'm going to look a little more later on. But for this pattern you've seen, you basically always need this hint. Now you may ask, well, okay, that's great, but wait a minute, isn't that cache there for a reason? Compiling the query every time, is that going to be very expensive? And well, you can guess the answer. Of course, it depends. I mean, let's say the users are only making a few searches per minute, and the compilation time, let's say 50 milliseconds. That's not a problem, not at least if that helps you to reduce the total execution time from, let's say, 5 seconds to 200 milliseconds. But let's say you would use that procedure static search for to look up orders on order ID 100 times a second. Our used CPU will be stinking hot. You could fry eggs on it. It's going to be that hot. So in that case, we need to look into something. And, well, we can do this. If we know that particularly this condition is very common, well, we can split the thing in two. So we're going to check if order ID is not null. We're going to say order ID is equal at order ID without any or, and then we can tack on the other conditions as far as they make sense, and there's no option recompile. And in the other branch, we don't have any conditions order ID at all, but we have option recompile. So this means that up here, we get a cache plan. Down here, we get compilation every time. So that's great. However, as you might realize, this makes the code more difficult to maintain, and you can have, well, 2, maybe 3 branches, but hardly more. However, let's say, because all this matters is, let's see, the less indexes there are, the less compelling option recompile becomes. Let's say you only have 3 search conditions that are indexed, and it might even be the case that you're actually even forcing the users to select one of these, and then they can add additional conditions. In that case, well, then you might be able to do this if you don't want to avoid excessive compilation. And if there is no indexes at all because it's quite a small data set, well, then you don't need it because it will always be scanned anyway. But most of the time when you do these searches, you have indexes on most search conditions. And of course, then you can't just have lots of branches. That's just impossible to maintain. And in high call frequency is a concern. In the general case, Dynamic SQL is a better choice for reasons I will discuss later. But before we go there, I would like to talk about multi-valued search conditions. So far, we have only looked at scalar conditions, like one customer, one product. But let's say that users also want to be able to search orders by employees, and not one employee at the time, but, oh, they want to see what, well, Ted, Frank, and Jane, what they have been up to. So, and one way to do this is to send in a comma separated list. That's quite popular, but with many people. So we have this parameter, and then we have a condition here, employee ID, and we have select, and we have a table valued function that unpacks this comma separated list into a table format. That's a common way to do this. And if you have not seen any one of these before, I got an article at my website, very short one actually, arrays and lists in SQL Server, which presents such functions. There is even a built-in one in SQL Server these days that I will return to a little bit later. And then we have this condition, employee CSV is null. And again, option recompile, if we don't pass an CSV, we will not call this function. Now, I'm more fond of table variables, table value parameters, because, well, we are in a database, so why not use table? So we can also do this, and I could make this int list TBL type. I did not say this on the previous slide, but that's a function that comes with Northscale. It's not built in that int list TBL. And also again, this is also one that comes, data type that comes with Northscale, but you need to have a table type and it has to be read-only. That's the constraints with table value parameters. And this one requires one extra step. I need to capture in the variable whether there is actually data in the table and then use that in the query. I can't put this exists down here because then option recompile is not going to work that fine. It's not going to handle the table variable as a constant. So, but then again, it's just the same thing. It's only going to search this table if table has value 1. So far, in theory, the logical thing is the same as doing scalar parameters. However, for performance, there is a potential problem because the optimizer knows less. If we pass a TVP, well, the optimizer will know how many rows there are in the TVP. But that's all it knows. It does not know which employees. And if all employees has about the same number of orders, it doesn't really matter because that is all the optimizer needs to know. But if there is a skew, that's a lot bigger problem. Let's say some employees, they sell screws and bolts and have tons of orders through the years. And other employees, they say, well, Porsches and Lamborghinis have 2-3 orders per year. Now, if you combine an employee ID with some other condition, Well, all depending on what you combine with. Maybe you want to use the index on employee ID, or maybe you don't want to, all depending on what kind of employee you have. Now that is if you have a TVP. What if you pass a CSV? Oh, well, now we come to the most complicated part of this presentation. Well, okay, so if you use a multi-statement TSQL user-defined function, one you write yourself. So if you're on SQL 2012 or more exactly compat level 110 and earlier, the optimizer will make a blind guess of one single row, which actually for these kind of searches is not too bad because presumably users are only going to let's put in a handful of employees. Now, if you are on SQL 2014 or 2016, or more precisely, compat level 120, 130, the blind guess will be 100 rows. And if you are on SQL 2017 or later, or compat level 140 or later, to be precise. Now, they made some enhancements there, so the optimizer will run the UDF before compiling the rest of the query, and now gets the cardinality. So now it knows how many rows there are. So at least we get the same results with the TVP. It still does not know which employees it gets back, but at least it gets back the number of rows. But this presumes, though, that you're making a plain select. If you're going to insert the data into a temp table or whatever, no, we're going to be back on the blind guess of 100 rows. Yes, Microsoft likes to make things complicated. But this was also if you write a multi-statement UDF. Now, if you use the built-in function string split, it's always a blind guess of 50 rows, even in SQL 2017. There's no interleaved execution, as it's called. And if you use something else like the CLR or XML, whatever, blind guesses. Yes, this is confusing. Thankfully, there is a solution for all of this, including for both the skew and the poor estimates for CSV. You take the data and you stick it in the temp table, because the temp table also has distribution statistics, and now SQL Server knows which rows there are on the temp table, or which employees there are. But even with a temp table, there's still one catch. You need to do an explicit update statistics on it, because if you don't, yes, it's like it says on the slide, you could be running with the statistics from the previous execution. Yes, this has to do with how SQL Server caches definitions for temp tables. Oh, anyway, we're going to look at this in a demo. So here I got a couple of static search 5, static search TVP, and it got this employee TBL with this table type. I'm going to check this variable, and down here I've added this condition or employee ID, or in select value for employee TBL, and there's still option recompile. And then I got the UDF. So now I got employee CSV, and now I got this condition. And again, this is not a built-in function. This is a user-defined function that I've added to NorthCal. I have to say employee ID, and this one also employee CSV is null. And here's one with string split. So again, I got CSV, and here's we're using string split. String split requires you to specify the separator, and the one I have in NorthCal, I've actually hard-coded it to be comma, and string split always returns strings, so I need to convert the value to int. But then the same logic here, only if it's not null, it's actually going to run string split and option recompile. And then I got static search 5 temp with a temp table, and here I said in the CSV, it could just as well be a table variable. And I have I have a table called hash emps. And if I have a CSV, I'm going to fill it up with the contents of my CSV or the temp table if I had one. And I do an update statistics on it. And then down here, I got employee ID in emps if I did have a CSV. So that was all of these. I'm going to create those. And we're not going to look at the execution times. We're only going to look at the plans, and we're going to look at the estimates. Not to dig too far into this. So we're first going to run this for 3 different employees at the same time. Now these employees, 901, 902, 903, these are Porsche guys. They have in total 64 orders in this database, so they're not very active. And let's see now, we're going to run, let's see, going to enable the career plan, and let's run this. And you can see here it says 187 of 28,821. So what does that mean? Well, that means that the actual number of rows that this operator had to work with, and because it's almost close to the select, that it's also the final number of rows, that was the number of rows we actually got back. But SQL Server estimated that we would get back 28,821. So that's a gross overestimate. There is a warning triangle here on the select, you may note see, which probably means that we got an excessive memory grant because too much memory was granted to be able to sort all these 28,000 rows. And that's bad because if one query execution gets too much memory and there are many parallel execution, we could run out of memory. And queries would have to wait to run until they can get memory, which they wouldn't need to if they only need to sort 200 rows. And also, of course, SQL Server may also bring on too heavy artillery to work with these 28,000 rows when they could use a much more linear plan. So let's then try the UDF. And now we get, well, the estimate now this time is lower. 187, still, of course, the same number of rows, but the estimate is lower, 16,640. And we can see it's 0 to 3. That seems a little funny, but this is because the table value function appears twice in the plan. And we go back here, we can see, well, cost 3 of 3 because SQL Server estimated 3 rows. And that's the thing. SQL Server only knows that we get 3 rows back. So it just makes an estimate from, okay, 3 employees and average employees handle this number of orders. Something around, well, why this estimate is lower than the other one, I don't know. But for some reason it's lower. But anyway, SQL Server thinks that we're between 8 to 9,000 rows, 8 to 9,000 orders lines per employee. Oh, let's now try the string split one. And now we have an estimate of almost 6 to 8,000 rows. And if we go here and we find the string split thing, it says 3 out of 50. Yes, the blind estimate. Now let's try the temp table with these 3 employees. And there is still an overestimate. There's still an overestimate by a factor of, well, 12, 13, but it's still a lot closer. We only estimate 2,600 rows now, or 2,557. So why do we still get an over? Because now SQL Server knows which employees we get back. So we can make a better estimate. But why is the estimate still so much bigger? Well, that is because in total there are around 750 employees in this database. And you may know that the histogram for a table can never be more than 200 values. So in this histogram step for these 3 employees, there are other employees with a more number of orders. So that's why we don't get any better estimate than this. Now let's try another employee, 337. This is a screws and bolts guy. He has, well, I think this is the guy with the most number of orders in the entire database. So let's now try this for the TVP. And well, this time, let's see if we can just scroll down. Yeah, this time we get more rows back, 42,705 rows back. But SQL Server now thought, well, there's only one employee, so I'm going to guess 9,607. And again, that's a big underestimate, and that would also lead to problems. Again, a bad plan. And this time we could get problems with the sort operator and the hash match here, for example, getting too less memory, so they would start to spill the disk. We like precise estimates to get as good plans as possible. I'm not going to redo this for the UDF and string split, but let's do this for the temp table as well. And here now we can see we actually get a quite good estimate. It's like 90% of the real value. That's a good estimate. If anything what is like within 50% of the actual values, we have to be considered as good if for a decently complex plan. So that's not a bad estimate at all, because this time SQL Server now, okay, this guy is quite popular, and also the other employees in the same histogram step. So it's settled for a lot better value. Finally, oh, that's enough. Finally, we have here some variations. We're going to do these searches with the UDF again for compat level 110 and 130, just to see the variations. And I'm going to reset the compat level to 150 again. And let's see this one. Well, this time the estimate was only 8,862 because we can see here 0 to 1. So this time SQL Server thought, okay, we will only get one row back from the UDF. Well, it just makes a blind guess. But here with SQL with the compat level 130, we have an estimate of whopping almost 100,000 rows because the optimizer thinks, oh, it's a UDF. They returned 100 rows. I think that's a good value. Yeah, maybe for other UDFs, other contexts, but blind guesses are just, well, kind of stupid. And finally, this one, we have one more procedure here, static search 5 temp new up restat. almost the same as the one with the temp table, except that there is no update statistics. And this gives some interesting effects. So let's see, going to run this. And let's see, we're going to run this again for the Porsche guys. And we have the same estimate as before, 2,557 rows. So that's okay. But now let's go and run this for the screws and bolts guy. And the estimate will be quite funny. It will actually be lower, only 1,680, because there was nothing, there were not enough changes to trigger autostats on the temp table. So we're using the previous distribution statistics. However, the cardinality changed. So because we are forcing recompile, so that's why the estimate went lower. But that's also, so that's why you need updated statistics to make sure that you're running with the accurate data. And because you can assume that the temp table will have a small number of rows, the overhead for updated statistics is small. Now let's go and leave all that behind us and move on to other things we want to do with our searches. So let's, for example, in this database we have two sets of order tables actually. We don't only have order and order details, we also have historic orders and historic order details. So we might want to expose a parameter called as historic. So if that one is 1, we're going to search these tables instead. And we can easily do this by using union. So here we're saying select order, we have the join orders and order details, and here we have the join historic orders and historic order details, and we have where condition on the variable. And option recompile is going to sort this out, so there's only one of these pairs will appear in the actual query plan. And this works, but the code's now starting to get a little more, getting a little more complex. And if you have lots of these tables, it maybe will get a little bit out of hand. Another thing you might want to do is to control the sort order. So for example, here we can say, okay, the user might want to say, I want to sort by order ID. Well, then we're going to use the order ID. By employee ID, we're going to use the employee ID. A customer name, we're going to use the customer name. But you may notice here, and we can easily do this with case. Case sorts this out very fine, and option recompile is going to make sure that we're going to sort by that column. But why are there 3 case expressions? Well, because a case expression has a static data type. A case expression always returns one and the same data type. If I would mix all these columns with different data types into one single case expression, which type would I get? Well, I would get the one with the highest precedence by the precedence rules that SQL Server has. And that is the date. Now you can guess what happens if you're now going to try to sort by customer name or product name. Yes, it's just going to crash with a conversion error. That's bad. So that's why there are 3 different sort case expressions. But option recompile is going to sort this out. If we're going to sort by order date, well, null, and SQL Server is just going to throw that away, and it's going to optimize the plan for ordering an order date. Now, this was one single sort column. Now let's consider this. Maybe you want to multi-column sort. You also want to let the users to show between ascending, descending. Oh, well, let's have a look at this here in static search 7. So this one has, first of all, it has at historic, and it's a sort called 1, and it's ascending 1, sort called 2, and it's desk 2. And it also has default values for them. And then we have this union all here, this join, and then I joined the U, 2 customers ID and product, not very strange. And then we got the order by. So okay, here's ascending 1, okay, and sort called 1, if it's any one of these, and then ascending. And then I got this is descending 1, the same sort columns, and then descending. And then the query goes on, and it goes on, and it goes on, and it goes on, and it goes on. And it's the order by clause is longer than the rest of the procedure. No. This just gets completely out of hand. This is a situation where Dynamic SQL is a lot better choice because the code just explodes. You don't want to write code like this. So this is not a good case for static SQL. So before we're gonna move to Dynamic SQL, we're gonna look at the different search problem. So we have a customers table, and we want to look up customers on either one of the customer ID, the tax number, or the name. And all of these columns are indexed. And we have this where clause. Customer ID equals at custody, and custody is not null. Or vatno equal at vatno, and vatno is not null. Or customer name like custom plus %, and custom is not null. And there is no option recompile. So what do you think about this? You might already, oh, well, wait a minute, we learned that already. This is going to be too slow because we want to use different indexes depending on what parameter that is actually provided. Yes, but if you look at this closely, you might notice that the and the or has changed places. Would that happen to matter? let's have a look at this. So here I got my procedure called cost-lookup, and I got this, and there's a top 20 because in some joke it puts in just, let's say, A, nothing more for the customer name. I don't want to overwhelm the UI. So we're going to create this guy. And let's run this for one customer ID and look at the plan. And you can see there's a clustered index seek there. And there's also an index seek, and let's see, there's the loops and else an index seek. So it seems to be using all three indexes. But why? We're only sending the customer ID. So why is it using all three? Or is it using all three? Wait a minute. Down here it says 0, 1. It says 0, 1 down here as well. 0, 1. But this one says 101. Why? Let's have a look here. So if we look at this pop-up down here, we can see something. There's something here called a start-up expression predicate. That now is not null. So what you see here, it's a static plan. It has to be because it's one source to procedures, one static plan. But the plan has dynamic properties. The plan can at runtime decide, no, I'm not going to seek this index. I don't need to because I did not pass the that ID. Of course, this is an index seek, so it's quite fairly quick, but imagine it's something else, which is more expensive, and we're going to avoid this. So let's see here. We're going to see we do this one for the tax number. And now it's 1 out of 1 here and 0 out of 1 here. And it still says 0 out of 1 down here. And now if I do the customer name, and there's more than one of them starting with Berglunds. And well, let's see here. All these pop-ups are sometimes a bit distracting when you're moving around. Oh, now it says 80 out of 1, 80 out of 1, etc. Because there was actually 81 matching. So this is quite nice. So let's go back to the slides. So this is known as a startup filter, and the plan has searches in all three indexes, but only one index will be used at a time because of the filters. So it's a static plan with dynamic parts. Very, very important. You need to have this condition at val is not null. Logically, it's not needed because if you have the condition customer ID equals at custody, well, if custody is null, that can never give any match. At least as long as ansinulls is on, and it should be on. But SQL Server does not have that shortcode, so this variable has to be there for the optimizer to consider these startup filters. When I've been trying this, I rarely, if ever, got this to work if the search columns have been in different tables. But you can try that. It usually works only when they're on the same table. Also, very important, always test that you get the plan that you intended. Just not think, oh, I will get startup filters here. It's going to work just fine. No, always test that you actually get that plan. And beware that parameter sniffing can trip you. So we're going to go back to this guy. I'm going to recreate it. And this time I'm going to start making the search for the customer name. And unfortunately, this is such a case because for this searching on the customer name, SQL Server thought, no, I'm going to do just one single scan. So you maybe could do this with hints or something else if you want that. But that's a quite neat thing. Here is another example where you can get startup filter can get in effect. So we're going back to our normal order search. Let's say we're going to add a search parameter called simple city. So we're going to find orders where the supplier of the product comes from a certain city, but we are actually not returning any data from the supplier's table. So we only need to do a check with an exists clause. And we can do this. So simple city is null or this exists. So now if simple city is null, SQL Server is never going to access the supplier's table because that will be a startup filter in this query. It's not going to, even if we don't have option RECOMPILE. Very important. If you have option RECOMPILE, well, then it's going to be optimized out anyway. But even without option RECOMPILE, there will only be access to suppliers if that supplier city is not null. I like to point out this is not operator shortcutting like you have in some languages like C or C++. I mean, if I would switch these conditions around and have the supplier city last, it will still be the same effect. SQL Server does not have any roles but operator shortcutting. It can very well evaluate conditions in AND and or in reverse order. And here's another example where startup filter strikes. We have already seen this But you don't, if this is all you have in your query, you don't need RECOMPILE. Startup filters will work very, very good here, very, very fine when you have union all. So you can use this. So only one of these union all will actually be active in the query, although both will be in the plan. I'd like to remind you before we leave the startup filters, always test that you got the filters that you expected if you want to rely on them. Now let's talk about Dynamic SQL. And I like to point this out from the start. Dynamic SQL means a higher level of difficulty. Oh, by the way, Damir, do we have any questions in the chat before I? Well, I hope everyone is still there. Damir, can you just give me a? Oh, I see there's something being proposed into the chat. Oh, still here, yeah. People are so silent. Okay. That's not fun, kind of fun. The meeting has just disappeared. It's always exciting to do with these virtual things. Oh, anyway, getting back to Dynamic SQL. So, yes, these searches mean a higher level of difficulty. Not the least do they require discipline from the program. I've seen so many examples on forums where people post Dynamic SQL code that produces Dynamic SQL, and you can't read it because it's just a complete mess. And sometimes I feel like maybe Dynamic SQL is more easier to write than read, but you really need to write code that you can read the next day or 2 years later. So it really takes discipline to get well code that you can maintain. And also, Dynamic SQL requires more testing. And what I mean by this, I will return to later on. Another thing to keep in mind is permissions. Because when you use static SQL, all the users need is permission to run the stored procedures. But if you use Dynamic SQL, that is not enough. They need to be granted direct permissions to the tables. Well, they don't need to because there are alternatives. You can use certificate signing or you can use execute as, and these are things I discuss in my article on my website called Packaging Permissions in Stored Procedures, but that's also one more level of complexity. So this is my thing. Well, it's not wrong doing this, but it's also one more step in that raises the hurdle for Dynamic SQL. All this said, Dynamic SQL gives you a lot more flexibility. Once you started going with it, you can easily do variations on how you build your query. Now, the core of all searches with Dynamic SQL is this system procedure called SP execute SQL. I guess many of you already know this one very well, but it's so important I like to discuss it. So what you can say what it does is that it creates a nameless stored procedure and saves it into cache, not to disk, but saves it into cache and executes it at the same time. Next time you pass that code, it's going to look up that procedure in the cache and reuse the plan. Now you may ask, if there is no name, how could it find the plan in the cache? Well, so what SQL Server does, it computes a hash from the query text. But that is the query text as is. It does not go and normalize, well, like trimming spaces, normalize spacing, trimming spaces, taking regards upper, lower, comments, etc. Add one single space at the end, and it's a new hash, a new cache entry, and maybe a new plan, or maybe the same plan. Now, SP execute SQL takes a number of parameters. The first one is simply the SQL statement to run. Now, be aware, it must be NVARCHAR. Most of the time, you can mix varchar and NVARCHAR forth and back, and SQL Server will let you get away with it. But SQL Server sometimes thinks, oh, you need to be aware of what you're doing. So sometimes it requires you to use NVARCHAR. This is such a situation. Inconsistency is just a hallmark of SQL Server. Then the second parameter is a parameter list, also NVARCHAR, and this syntax of this parameter list is exactly the syntax of the parameter list to a stored procedure. And the remaining parameters are, well, those are the parameter values for the parameters you specified in parameter list. So let's have a look at this. So first here, I got two variables here that I always have when I work with SQL. I got one called SQL, which is my SQL statement. And the data type for this one should always be NVARCHAR max. Don't make it a limited, because all of a sudden you have more characters in your SQL string that you actually have. If you say NVARCHAR 1000, and then all of a sudden there's one 1020 characters, whatever, in the string. Or, well, there's only 1000 characters in the string, and you will get probably a syntax error. I remember one particularly funny case on the forums. The guy, well, the query did not work, of course, and his SQL string was 51 characters, but he had declared his SQL variable as nvk 50. Yeah. Now the parameter 4000 should be enough. If you need max here, you have too many parameters, believe me. And then I got two more variables here, but they're only local for the example, so that's why I got them separately. So here's got my SQL statement, and there's no need for dynamic SQL here, but this is just a quick example. So say select at count equals count star from dbo.orders, where customer ID equals at custody. And here's my parameter list, a custody and account, which is an output parameter. For these dynamic searches, you rarely have used for output parameters, but I threw that in because I wanted to show you that it is exactly like the parameter list for the procedure. And then I'm going to run this, so I can send in SQL, my parameter list. So here's some actual parameter values, and I get this is an output parameter. And although this one is called count and this one is called count, they are not the same parameter because they are two different store procedures. And this is furthermore emphasized here in this second example. This time I don't use these variable params, but I simply specify the parameter list in line. I tend to do this when I only have, let's say, 2-3 parameters. But if I have a long list of, let's say, 10 parameters, I would use a variable. And also I can use name parameters here. So custody equals and vnet. And here, well, at count equals at count 2. That is, my formal variable is called at count, but the actual variable I'm passing is at count 2. So they don't have to be the same name because these two at count are two different things. I can just quickly run this. You can see I get back some results. Now, let's move on and look at dynamic search 1. You may recall that when I talked about static search 1, I basically only used one single slide on that procedure. I will need a couple of slides on this one, and I would start making a quick walkthrough of this procedure, so just you know what it's going to anticipate, and then I will come back to this one later on. So here's the parameter list. I got my employee string and employee table as well, and also debug parameter that I will return to. Here I have the variables for the SQL and the parameter list. This one I will return to. Here is the select list, my join conditions, and here I go add in all the where conditions. Here's my order by clause. Here I use the debug thing. Here I set up the parameter list, and here I make the call to SPQ to SQL. So, and now let's look at this in more detail. So first of all, this is the first part. I declare my variables, and this one I will come back to again in a second. My select list, I've just shorted it out for the slide, and here are my join conditions. A few things to call out here. First of all, I need to say DBO dot. Well, I should do this. You may have observed this, or you may or may not have observed this. In my store procedures, I did not say DBO.orders because I think as long as everything is in the DBO schema, saying DBO dot before every table, that's just 4-character noise. If you do use multiple schemas in your database, you should always put in, also for the tables in DBO, put in DBO to avoid confusion. But if you have everything in DBO, which is quite common, I don't like to do that. But you should do this when you work with dynamic SQL. And the reason for this is that users could have different default schemas. So let's just consider this. We have two users, Jack and Jill. Jack has the default schema Jack, and Jill has the default schema Jill. Now, when Jill is running this query, and if it only says from orders, this means if there is a Jill.orders, well, we should use Jill.orders, not DBO.orders. Now, the problem with the cache plan is that even if there, at this point in time there is only DBO.orders, Jill.orders could appear in any second, or at least so SQL Server thinks. So therefore, Jill and Jack cannot share plans, because if Jill.orders turns out, we need to validate her cache entry, but not Jack's, because Jack.orders is still not there. It should not be affected that or the fact that Jill.orders was created. Now, the problem is if you have lots of these users, everyone with their own default schema, you litter the cache. Well, lots of cache entries with the same plan. That's bad. That's a waste of memory. Now, in practice, users often have DBO as their default schema, but don't rely on that. So that's why, as best practice, you should always put in DBO. Then we have this condition here, where 1 equals 1. Well, that's what something SQL Server knows how to throw away. It's not going to bother SQL Server. But the point with having it there is that then we don't have to think about later on when we add conditions, do I already have a where there or not? So this makes things just easier. And finally, this variable at NL, which stands for new line, it's just a new line. Character return, line feed, character 13 plus character 10. And the reason I put this in is I want my Dynamic SQL to be readable. Because every once in a while, there will be problems. The code will not work. I will get a syntax error or I will get the wrong results. And I want to look at the Dynamic SQL to understand what is going on. And then I don't want it to all one single long line. Not the least if I get an error, okay, it's an error on line 5, yes. And line 5, that's just 10,000 characters. Good luck of finding where there is. So that's why I want to have line breaks and make the query decently readable. That's something you learn by working from the hard way. Then we go on adding conditions. So, and this is just a handful. So I go to check if do we have an order ID? Well, then I go and add the condition order ID equals at order ID. If from date is not null, well, I add the condition order ID is greater or equal from date. It's customer name. Well, it's not null. I'm going to add the condition like custom plus %. And then there's a whole bunch more of these. Again, a few things to call out here. So this operator here plus equals, make the code a little shorter. This shortcut operator was added in SQL 2008, so I don't have to say SQL equals at SQL plus. Here is a very important thing. This is about discipline. After each opening single quote, put a space. So you make sure that statements do not run into each other. And this is very much one of these things about discipline. And also here, I'm going to put a new line after every row. I don't want all the conditions in one single line. I want them to be split up so I can read the query and also easily find errors by using the line number. And finally here, well, here I need to include a single quote in the string. And as you may know already, if you need to do that in SQL, you need to double it. That's the way you do it in SQL. In other languages, you use backslashes, but in SQL, like Pascal and a few more languages, you double it. Then we have the multivariate parameters. So these, well, we're going to check if there is in the data in the employee table. I'm just going to add this condition where employee table and select val from the employee table. If the string is not null, well, then I'm going to add this condition. Employee in the use the select n from DBO in this DBL, and yes, DBO dot. Again, I need to specify DBO dot. If I don't do, well, SQL Server has to consider, or maybe a jack dot list in test to DBL could appear at any second. It's the same thing. Also, with everything which is bound to schema, I need to use DBO. And this is quite shameful for me. I had my article up for several years on my website, and with the DBO missing, very, very embarrassing. Now, some people here might be thinking, couldn't we do this instead? Don't even think about this. Don't even think about this. This is very bad, and why this is bad, we will come back to in a few slides. Now, then we have the debug parameter. When you work with the Dynamic SQL, you should always have a parameter at debug with the default value null, and then you have this statement: if at debug is equals 1, print SQL. Always, because every once in a while, that SQL will error out. You will get a syntax error or you will get incorrect results. And if you don't see the SQL, how are you going to figure out where their problem is? It's just you will be moving in a completely dark room. So always put this one in. And then finally, we're going to make the call. So I'm going to set up my parameter list. And here I don't have to consider, did I actually pass an order ID? No. I'm just going to list them all. And some languages are going to say, well, you specified an order ID as a parameter, but you don't use it. Is that okay? But SQL is not going to bitch about that, thankfully. So we just can do this. So just specify the parameters and then just make the call and specify all the parameter list. Well, one thing, again, for the table type, I need to put in DBO or else SQL Server thinks, oh, wait a minute, that could be a jack.in this table type that could appear in a second. And here we come to the really embarrassing part of this presentation. It was only last autumn that I realized that this DBO was missing. I've been doing this session for, well, 5 years or so, and the article, and with this DBO missing is just, well, yes. But now I think it should be okay now. I think I even tested it, so there's no problems anymore now with the missing DBOs in this function. So let's have a look at this in a little more detail. We will look at this procedure again. So we had this one, the parameters and the select. And it goes on with all these conditions. And one thing you may note here is that I'm now here at line 94. Oops, in the UI. So, and let's say a few lines at the top. Let's say 90 lines of code. That's a quite bit longer than static search 1. So I told you, Dynamic SQL is going to give you a higher level of flexibility. So let's see here now. I'm going to try some examples. So let's just make a search for an order ID 11,000. and I get back my orders, and here's the statement. Now, after all this work, this looks good. I'm not even going to look at the query plan. This is going to use the clustered index. No problem. This is just perfect. Oh, let's see. We can try something more. Let's make a search of two, a product ID and a customer ID. This is not equally clear cut which query plan, which index is going to use, but it is more or less as good as it can get. So once we have worked it this far, we get very clear cut queries. That's quite nice. Here we can make a search for, well, employee string and a region. And let's see. Yeah. And that looks quite good as well. Oh, we can do one more search, but hey, this debug parameter is for WIMPs. We're going to search for customers in Paris that have ordered product 76. Oh, must declare the scalar variable at city end. Oh, maybe debug is not only for WIMPs. we have to look at this. Let's see, where is my, oh. We need to look at this. Must declare, yeah. Oh, city and, oh, yes, that's wrong. But what's going on here? We have to look at the code. Let's see here. Oh, some joker has commented out the new line here. And what about the product ID? Oh, the space is missing. Remember what I talked about requires more testing. Exactly this combination fails, city and product. Had I also searched for region, it would have worked out because here is a space and here's a new line, and that would have saved the show. So that is one of the devilish things with Dynamic SQL, because if you have made these mistakes because of your lack of discipline, well, then you can get this particular combination that fails. So that's kind of devilish part with Dynamic SQL. Now, unfortunately, not all users do this as I use parameters. They build inline the values, and this is just why they do this. I don't know, because this is a lot more difficult to get right. But maybe the abstraction of using parameters, maybe that one is more difficult to grasp for newcomers. Or, well, I even seen experienced programmers to do this. Anyway, so this is bad. Well, order ID is not null. Then we say order ID equal and convert varchar 10 order ID. City is not null. Then city equals 3 single quotes plus at city plus 4 single quotes. And then we have the one that I told you, don't think about this. Yeah, this one looks simple, very simple. But, well, we're going to look more closely at this, and we have the procedure called dynamic search. Bad, because it is, well, bad. Oh, there's an employee string. There's no table this time. There's no parameter list because there are no parameters. Everything's being inline in this procedure. And I don't even use execute SQL. I use this form, exec parenthesis at SQL. It's an older form of SQL for running the Dynamic SQL. I tend to use that when I don't have any parameters. Maybe I should not do that. Maybe I should always use SPQ SQL. But this might be, I'm an old fart. But anyway, as long as I don't have parameters, it doesn't really matter. So, and let's now try some examples. So, going to run Dynamic Search 1 and Dynamic Search bad for order 11,000. And look at the query text. So this one uses at order ID. So this means if I also now going to search for order ID, let's say 11,002, well, it will be the same query string. There will be no change. But here it says 11,000. So now if I search for order 11,002, it will be a different query string, a different hash, and a different cache entry. So if I make a lot of these searches by single order IDs, there will be lots of planning in the cache. That's called cache littering. It's really bad because it takes a lot of memory and also means a lot of extra compiling. Now here's another one that things go wrong. So I'm going to search for customers who have ordered from Lviv in Ukraine, and it's spelled in Ukrainian, and they ordered the product stout. So let's try this for both Dynamic Search 1 and Dynamic Search bad and see what happens. And oh, I don't even get a result. I get the wrong results. But I do get results here. Let's see why. Well, here it says it's equals city and product name equals product name plus %. That's great. But here it says city equals Viv. Well, what's the problem here? Well, there is no n here. So because there is no n, the data type of this literal is varchar. But that means the only characters that are available in varchar are the one of my of my code page. Now, I don't have Ukrainian collation. I have a Finnish Swedish collation, which means that I don't have any Cyrillic characters available in varchar. So SQL Server is going to convert this one to be use fallback characters, and these are the general fallback characters, just question marks, and that's why I don't get a hit. The lousy programmer who wrote this should have put in an N here, or maybe it's here, or maybe even here. No, I don't know. It's just, this is just too difficult to get right with all these quotes. It's just so much easier to use parameterized statements. Anyway, let's move on. And now this time I want to find customers who are located in the same city as the customer RegC to see what they have ordered. And I'm going to run these, look up the city, and then run a search. And I get incorrect syntax near Emilia, unclosed quotation mark after the character string order by order ID. Well, it turns out this customer is located in Reggio Emilia in Italy. And there's a single quote in the name. So that was the end of that character literal. But did that code take that literal single quote in the regard? No, it did not. So that was also a problem. And finally, this one, we're going to use the employee string, and we're going to send in this seemingly piece of nonsense, 0 parentheses, xp command shell, 0 C:, and then some funny query. And now you're saying to yourself, oh, okay, this is going to explode big time, just like it deserves. Well, let's see if it explodes. It did not explode. It returns an empty result. It returns, seems to be the contents of my C drive. I'm glad it didn't say forward C:, and then it returns one single already. So what did I get? Well, first of all, I got employee ID in, well, this is the query. This first query, employee ID in 0. Here's my xp command shell. And then this is the query that I sent in. What it serves to is to make some meaning out of the order by condition here. And these comments here are used to neutralize and remove this parenthesis, which was intended to be up here. Now you might say to yourself, okay, yeah, that was fun, but hey, wait a minute, I'm getting hungry for dinner. I move on with the serious stuff. This is the most serious stuff in this presentation. What you have witnessed is an example of SQL injection. Many times when you hear about sites getting hacked, it is SQL injection. Now you might say to yourself, it takes forever for a hacker to find a hole like this. First of all, people who do this are not really hackers anymore. People who do this, they are in it for the money, because there are lots of money to be made for this. You can, well, plant ransomware, just encrypt the disks and, well, please send me all these bitcoins and I will de-encrypt them or send you the encryption key. Or you can, for someone else wants you to do bad things, just going to plant something else which you're going to use for a DDoS attack on someone else other side, or you can steal information. And not only this, these guys have plenty of good tools on their hands. I haven't tried this particular example, but another colleague of mine, he showed me a tool he had, and that was a site with SQL injections. I would say he found them within less than a minute. So yes, this can easily be done. So this is bad for several reasons, but the most important reason this is bad is that it opens for SQL injection. Do not use any of these patterns. They're really bad. Now, let's talk more about cache and compilation. So if we're making these 3 searches with static search for 3 order IDs, well, we get 3 compilations and we get 1 cache entry, but it's never used. If we make it with dynamic search 1, we get 1 compilation and 1 cache entry, which is reused. And that is why dynamic SQL is so much better when we have a high call frequency. For any combination of search parameters, we get 1 single cache plan that we can reuse. With dynamic search bad, we get the worst of both worlds. We get 3 compilations and 3 cache entries. And here's another angle of the whole thing. On the left, option recompile. Well, compilation every time, dynamic SQL with parameters, we get a cache plan per combination of parameters. So with option recompile, well, we get more compilation than we need, because every once in a while, we will generate the same plan. Whereas with dynamic SQL, we get a lot less compiling. We can reuse plan for every combination of parameters. However, this cuts both ways, because with option recompile, the plan always fits the current parameters. But when we use cache plan, we can get a problem with parameter sniffing. So here's an example of this. So here I have this script. I got 3 searches. And all of these 3 searches are going to use static search for, dynamic search 1, and dynamic search bad. The first search is the customer ERN to C, the guy with 10% of the orders in the database for a single day. And then we have $R, one order in the database, and for a full year. Again, static search for, dynamic search run, dynamic search bad. And finally, all these three procedures to search for orders with status E, arrow orders. And I'm going to run all of these to see what the execution times are. And yes, I got the result that I wanted. Sometimes this demo pulls my legs a little bit, so I have to rerun it, but I don't have to cheat this time. Now, for the first search, it seems like dynamic search bad is really a big win. It's so much faster than the other two. However, that's a mirage. The reason why it's so much faster is seen here. The result set for this grid did not have to be rendered because it did not fit on the screen. That's one thing you would keep in mind when testing with the Management Studio, and particularly when you have short execution times, the grid can actually distort your numbers, so be careful. But here, there is really a difference. We can see these two are fast, this one is a lot slower, and same thing here. So why? Well, let's go and look at query plans. And we're going to move directly to look at this one, $R for a full year for static search 4, and see what plan we have here. Well, we have already looked at it, but that was a while ago, so we're going to repeat it. And we can see there's an index seek on the custom ID X, and then there's a key lookup. So it only uses the index on custom ID. Now with dynamic search 1, which index do we get here? Or so which plan do we get here? Well, let's have a look at it. And it uses index seek and index seek. It uses both the index and order date and custom ID and makes a hash match. And you might notice there is a warning triangle now on the operator, which means that the hash match is now spilling to disk. And the reason for this is because it's reusing the plan that it got compiled when it was searching for ERN to C. So this is a case where parameter sniffing beat us and we got a bad plan. Now the search for arrow orders. So let's see, static search 4. So what plan do we get here? Well, we get an index seek on the status X, exactly the plan we wanted. It uses the filtered index. But dynamic search 1 seems to be doing something else. So let's try that. And let's see what we have. We have a parallel plan. And let's see what do we have over to the right. Closet index. Closet index. Scan, it says up here. It's closet index scan. So why is it not using the filtered index? Well, it's because it's a cache plan. But wait. We have not run any queries. We have not run any searches for status orders on dynamic search 1 yet. So how could it be a cache plan? That's true. We haven't run anything, but still it's a cache plan, meaning that it must be correct for any input of the status value, including C. Of course, why search for status equals C only when it's 99% of the orders? That's just crazy. But SQL Server never makes such thinking. No one is going to search for that, so I've got to make a plan that was incorrect for that value. Ha ha ha. No, it doesn't do such things. It make sure that the plan is correct for any possible input. So we can see some challenges here with using Dynamic SQL. Let's now look at how we can address them. First of all, option recompile is still possible to use. If we know that this particular combination is problematic, we can throw in option recompile as long as the call frequency is not a concern. It's a completely fair game. If we're using Dynamic SQL for a completely different reason than high call frequency, don't be shy with using option recompile. But let's say now these searches are actually very common, maybe because this is a very busy site. We have lots of users making these searches. So what can we do then? Well, here is one thing that seems kind of silly at first. We're going to look at the length of the data interval, and all depending on the length, we're going to add comments. If it's just one single day, we go, well, single day. But what's the point with this? It will be the same query. The point is we're going to change the query text. So it will be different hashes and different cache entries and maybe different plans. Now, this requires that you understand your data. You have to understand where are the limits, where should I get different plans? And it's less granular. Maybe in some cases you will not get the very best plan, but at least you get a lot less compiling. Here's the variation, which will give you more plans. But what I'm going to do here, I'm first going to add a comment character. Then I'm going to say, if it's up to 7 days, I'm going to say, okay, days. And then it will be the number of days. If it's up to 35 days, I will be the number of weeks. And beyond that, it will be the number of months. Now, this is guaranteed to give you some entries with the same plan, but still with a lot less risk for poor plan choices. And what to do here is, well, Depends. But I like to point out, this also shows you the power of Dynamic SQL. It's quite easy to add these things to just tweak the query if you need to do that. Another situation you may have is that you have a very big skew. Let's say that 60% of all customers are in London. Well, then you don't want to query with city being sniffed for London and then being used for Paris, or vice versa. So, okay, London is our most common value. I'm going to hard code London because it's a very special value. Or maybe I have a customer who is, it's very, very big, very important. So when this customer calls, I want the really best plan. So I'm going to hard code that special value. Also, we have this status value with very big skews, and you might always say that, okay, you know, new orders or error orders, that's two different searches. So I'm going to inline that particular value. And I do that by using the function quote name, which is going to delimit the value within with the delimiter that I use, in this case, single quote, and double it if needed, just in case the user for some reason or the applications passes a single quote. I don't want to have a compilation error. But don't go in inline on values on general basis because you will litter the cache. Do this in only very, very special cases. Now, for filtered indexes, if you run into these, and particularly these are a problem, you can do this. You can add the filter condition to the query. So if status is not C, you can add the condition that status is not C. And let's have a look at this Dynamic Search 2, which has not all of these things I've showed you here, but some of them. So here I got the data variable, and let's first see the status variable. I'm going to do exactly what I had on the slide. I'm going to add the condition status is not C. And now, if I go to both the from date and the to date, I'm going to add those comments. And down here I got London. So if it is London, I'm going to hard code London. And that's about it. Let's go and create this guy. And let's go and run this. Or rather, we'll run, look at some, we'll run some of the demos here. And Dynamic Search 2 and search for error orders. And look at the plan, of course. And now it's using the index seek. It's using the status index. And this is the final query. Status equals at C. And status is not C. We're different from C. Thus, the optimizer says, okay, I can use the filtered index. Great. Now here we can look at these two and both look at the Dynamic SQL. Sorry, look at the generated SQL and at the plans. Well, we can look here. It says single day, and these are the conditions. And here it says more than a month, and it's the same conditions. But we go and look at the plans. We can see here it uses index seek on both indexes. But if we go here, it says index seek and key lookup. So it only uses one of the indexes. So we were able to get different plans. But we could still get sniffing problems if these comments are not granular enough. And here we have the search on cities. So, well, search for Proto 802, either customers from London or from Zagreb. And let's see. Here it says, well, London, and here it just says it's at city. And if we look at the plans, this is a nested loop. There's a clustered index something, and a hash match. So we got different plans. Although in this database, London, I think London is the most common city, but not 60% of the orders. I don't think it's even 5%. But that was as good as I could make it. So a few more things. We talked about selected sort orders. Oh, we were thinking Dynamic SQL. We could just do this. Order by its sort call. And that's great because now sort call could be a list of columns, also with ascending, descending included. Oh, not so fast. There is a risk for SQL injection, so we need to use quote name. But wait a minute, SQL injections, that's no problem. I write the UI. I have full control. The users can select the columns from a drop-down. They can't inject any code here. Never make such assumptions. You're writing that code today. Now, 2 years from now, someone decides to slap on a web UI on that store procedure, and they are sending the sort column as a parameter in the URL, and it's wide open for SQL injection. So you need to use quote name. If you don't give it parameters to quote name, it will simply delimit the name in single quotes. Brackets. And if there is a right bracket in the name, that right bracket will be doubled, thereby protecting you against SQL injection. But this also means that now you can't have a list of columns, so you can't have ascending, descending, but you will have to need sort call 1, sort call 2, or, well, you can send in an XML with sort call if you think that is fun, but you will still need to use these variables when you build the string. And if you send it in column names, you still have a dependency on the column names. That's also one thing. Well, maybe not a big deal, but let's say this, that you have, let's say you have order ID now with a mixed case, and then the DBA decides to refactor the database. Everything is going to be lowercase, but it's going to be with underscores, order underscore ID. And he thinks, yeah, I can do this because it's only the database, because he's going to fix all aliases and anything. The client will be unaffected. But since you're passing column names from the client, that's a bad thing. So it's quite better to do something like this. You send in a logical string, which then in the case expression is being mapped to the column thing. It's quite similar to what we did with static SQL, except there is only one case expression, because now we're only mapping strings to strings. We don't have to consider the data types. And also, if we have is descending, well, then we can add ask or desk, depending on the value of the parameter. One thing to watch out for, though, we need to have an else clause in our case expression, because if we don't have an else, we will return null, and then the SQL string will be null, and nothing will work, not even our debug print. Everything will just be blank. So we really put into some defaults here, maybe other column, or maybe there's something which gives a syntax error, because we never know what the client might be up to. And then we have alternate tables. We looked at this, and again, don't send in table names, but translate them, a parameter that translates the DBO to table name. So, for example, we have this at historic. Well, it's quite similar to what we did before. Or we don't have union. We just simply can build, okay, DBO dot, okay, if it is at historic, we're going to add orders, or else historic orders. Again, here for order details or historic order details. So let's have a look at this in Dynamic Search 3, where I have these extra parameters at historic, sort code 1 is descendant 2, sort code 2, and is descendant 2, and the debug parameter. And well, here's the from. This is slightly shorter what we have in static search 7, where I had a union, because, well, so this is also one of the powers with Dynamic SQL. You can sort of easily just tweak in something to build a string, and it increases the complexity of the code a little bit, but not that dramatically, because you've already started of building the string. But again, if you do this, you still have to think about, how do I format the code so I can actually read this, and someone else can read this in 2 years later. And here I got my sort thing, and I did this. This is done differently from on the slide. Here I'm actually setting up a mapping table from the logical name to the actual column, so I can reuse it in the two case expressions. Or rather, I don't have a case expression, but for the two sort columns. So the first one is supposed to be mandatory. You may have noticed here that I had a default value for this one to be order ID. This one is null. So, and okay, I'm going to do an order by. I have an isNull, because if for some reason the client sends in something unexpected, I'm going to use the default, so I don't get back null. And then I just tack on ascending, descending. And sort code 2, well, I have to repeat the whole thing, add a comma if needed, and then do this null thing. So yes, the code will grow. It's a little bit tedious, but compared to static search 7, where things just exploded, this one grows linearly. If you add one more sort parameter, well, that's just one more of these. And did I have some searches here at the end? Well, we have kind of a look at this one. These are not too exciting, but let's see here. Well, it produced it all by customer name ascending, order ID ascending, and we had a parameter list which says London. And yes, it's also as historic, so you can see here it uses the historic tables, historic orders, and historic order details. And anyway, so that was. And of course, that is not the end of it. We might want to even do more things. So, for example, maybe we don't always want to equal conditions. Maybe the users should be able to select greater than, or different from, or whatever, or what columns that's going to be returned. Maybe some grouping and some aggregating. Could we do this with Dynamic SQL as well? Yes and no, but I think there is a limit for what you can do with Dynamic SQL in this procedure. It's not so much that you can't do it, because it's all a matter of building strings. But how would you express all of that in the parameter list? Of course, you could send out an XML document, but it's not really that fun, is it? No, I think if it gets that dynamic, I think it's a lot better choice to do the whole thing client-side in a class with some nice, clean, object-oriented interface, which is a lot easier to use. And I like to point out, I think this is perfectly all right. Of course, one thing you need to have accept if you do this. Now you must grant users direct permissions on the table. If that is a no now, you will have to consider do this in a procedure. But if else, I think this is a fairly perfect OK solution, even if the policy for the rest of the system, we use stored procedures. But if you have something, these very dynamic searches, it's a lot better to do this client side. But there's one thing you must never do. Never build some of the SQL syntax in the client and send that to a stored procedure. Either you do it all client side, or you do it all in the stored procedure. But don't mix, because if you do, you get a very tight coupling between stored procedure and database. That's going to give you a big headache. And I said here, yes, the way to do, I think this is best to do client side. However, a few weeks back, I attended GroupBy. I also spoke at GroupBy, and Eitan Blumin from Israel, he had an interesting session, which is sort of the sequel to my session here. It will eventually appear on YouTube, on the GroupBy channel, but this far I only have his links to his works on the site, so on his website. So what he does, this is exactly aimed at these kind of very dynamic searches. So he has, it's a table driven, so you can set up which conditions you have in the UI, then adds the column as needed, and then he's built some XML. And I haven't looked at the code, but he must be, I think he has Dynamic SQL that generates Dynamic SQL. He must be very crazy to look at. So to provide my sanity, I didn't do it, but it's a quite interesting thing. And so I just like to mention so if you have these needs, you might want to be interested to look at his works. Now, before I draw this to an end, I'd like to make a quick summary. So we have looked at two ways to do these searches: static SQL with optional recompile, and this is good for the very simple cases where you all have a bunch of conditions. But if you need to sort of add different things, different flavors to the searches, complexity starts to grow, also when you have high call frequency. A special case is when you can rely on stub filters, when you don't need optional recompile. These are quite special cases when you have like the conditions reversed, as I showed you, but test carefully if you want to do this. And then we also looked at Dynamic SQL. It's just too much hassle for the simple cases. But as complexity grows, it scales a lot better in complexity, or if you have to deal with high call frequency. Which to use is a choice, it's a decision to make from case to case. If in doubt, I say start static, but switch to dynamic if needed. So that was all for me. My name is Erland Sommarskog. Here's my email address. So if you have any questions that I don't answer right now, you're more than welcome to drop your line. And here's on my website, sommarskog.se/present. You find a list of all my presentations. Now this one should be at the top. And there is all slides and the scripts, including to create the database. And to create Northgale, you need to run two scripts. You first have to create Northwind and then create Northgale. So that was all for me that I had to say right now. But I'm, of course, welcome to answer questions or anything else you want to chat with me.